class. Today we're going to discuss taxonomy. We're going to discuss taxonomy. So our objectives are twofold. One, we're going to write a testable question or hypothesis when given a topic. And two, we're going to classify organisms from different kingdoms at several taxonomic levels using the dichotomous key. So that's the part we're going to focus on today, using the dichotomous key. So to start off, I'd like for everyone to go to templates. Go to the templates folder. When you get into the templates folder, it should say Oregon State or Common Trees of the Pacific Northwest. Common Trees of the Pacific Northwest is going to open you up to a website. Now, once upon a time, we used to have dichotomous keys that were small, and you would flip them as you were going to observe. But here with technology, we don't have to pass out the keys anymore. We can actually use them online. So when we look at a dichotomous key, all right, first question is the word dichotomous. Does anybody know, or can they explain what a dichotomous key is? All right, no Google. Just take a guess. All right, let's look at the prefix di. Does anybody know what di means? Di means two. So a dichotomous key is simply where you're going to have two options to identify an organism. It's either going to be this or it's going to be that. So when we look at our dichotomous key, and when we look at classifying organisms, we're going to choose between two different features or two characteristics of a certain organism. So to achieve our goal and to identify these trees that we're going to look at, we're going to use inductive thinking. When we use inductive thinking, the first step we have to do is make an observation. So I have some pictures that we'll look at, and then we'll let you make your own observations as we go. You look at the observations. From the observations, you identify a pattern. From that pattern, then you could make a hypothesis. And from a hypothesis, if you're going really big in the science world, you can make a theory off of that. And that is how scientific theories, that's the basis of scientific theories. Observations, patterns, hypotheses, and then theories. So when we look at a dichotomous key, two choices. Brayden, would you do me a favor? You should go over here and turn the light off. Alright? So, before we get to the key, inductive thinking, we're going to look at this.
Okay, by the door.
Alright, right behind the piece of paper. Alright, we make an observation. We make an observation. He just flipped the light switch down, and what happened? He flipped the light switch on, and what happened? Down. Alright, so now we're kind of seeing a pattern. And the pattern is, if the lights are off, then the light switch must be down. So that's using your inductive thinking. Now, here's the issue with inductive thinking. Is that always accurate? Are the lights off every time the light switch is down? Yeah. What could happen?
It could be switched.
Alright, something could be wrong with the switch. Alright, the power could be off. Light bulb could be blown. Okay, so when you use inductive thinking, it's not always right. Alright, but we're using our observations. Thank you, Mr. Roberts. So, when you make your observations, there are chances that you could be wrong sometimes, but it's still part of the thinking process. Alright, when we're looking at taxonomy, somebody tell me what kind of animal this is. Looks like a what? She said it looks like a muskrat mixed with something. Looks like a bear in the mouth.
Yeah, it does.
Go ahead, I mean, just take a guess. Looks like a dog.
Mixed with a rat.
Mixed with a rat. Alright, actually this is a Madagascar weasel. So Bridget was actually fairly close, similar to a muskrat, but this is a weasel. And in Madagascar, there are no cats. So this weasel has actually developed some characteristics of top predators, which makes it very cat-like. The long tail, you notice the legs, the posture of it, it doesn't look like other weasels. So when we're using our observations can sometimes be wrong because this will make you think it's something else other than the typical weasel, typical otter, other animals that are related to it. Alright, so let's look at our key. On our key, I'm going to describe a tree, and I want you to select. Alright, this tree has needles. So select needles. I'm sorry, let me go back. This tree is a conifer. This tree is a conifer, so select conifer. This tree has needle-like leaves. The leaves are clustered. And they're in groups of 2 to 5. So what type of tree are we looking at? We're looking at a pine tree. Right? That's how the dichotomous key works, and it works off of our observations. So let's click back. Alright, the next one is a broadleaf tree. The leaves are simple and they alternate. The leaves are deeply lobed. They are deeply lobed. Alright? They're also what we call palmate leaves. Alright? So the leaves are palmately lobed. And they are star-shaped. So what type of tree is that?
Sweet gum.
Sweet gum. Alright? And I selected those two because even though these are trees of the Pacific Northwest, we're here in South Louisiana, we know pine trees, right? And we know sweet gum trees. These are the trees that we have that most likely turn colors. So, how you would use this, you would go outside and look at a leaf, look at that tree. There you're making an observation. You look at all of the leaves of that tree, and now you're recognizing a pattern. It's not just one leaf. From there, you look at the characteristics of the leaves, and with your dichotomous keys, you have characteristics of the leaves. You make a pattern. So let's go all the way back to the beginning. So if I told you that we have leaves that are needle-like, real thin, the hypothesis you can make, your educated guess, would be that it is what type of tree? Alright, not necessarily a pine tree, but think bigger. A conifer. Okay? Because the conifers that we looked at had small leaves. If you're looking at something that has bigger leaves, the flatter, wider leaves, we could assume that it's what type of tree? Broadleaf. Now, using your observations, your inductive thinking skills, we see pine trees and spruces and other conifers. What do they have on them that we recognize? Especially this time of the year, they start falling to the ground. Other than the needles. Cones. Alright? So you can say that most conifers have cones. Most conifers have cones. When you look at the broadleaf trees, alright, they change colors. And they have fruits. Very good. Two very good observations. So your hypothesis could be, if you see a tree, alright, if it's a broadleaf tree, you could say your educated guess would be that it has fruit and it has leaves that change colors. Or if you see a tree that's a conifer, your educated guess could be that it's going to have cones and real spiny leaves. So, making observations. What if you run into a tree that has broad leaves, the wide leaves, but it also makes cones? What would you say? Huh? Well, it's not a mixture, it's either or. Or a dichotomous, it's one or the other. What's your answer? All right. So what's our first choice on our dichotomous key? All right, conifer or what? Broadleaf. So we only use 2 from the beginning, because if you use 3, then it can get a little confusing. So the first characteristic of our leaves are what? Broadleaves or conifers. All right, so when we do it, we're going to look at whether it's a broadleaf or a conifer. So even if it has the flat leaves, the wide leaves, it's still going to be considered a what?
Oh, broadleaf.
Or broadleaf. Okay, it's still going to be considered a broadleaf. All right.